Hello and welcome to Lecture 7 on Special Relativity. In today's class, we're going to talk about the notions of a spacetime interval, and then we'll talk about spacetime diagrams. So we'll begin by talking about so-called Lorentz invariant quantities, that is, quantities that remain the same no matter which inertial observer you talk about. Now, this will be quite important because, as we've seen, in Galilean relativity, lengths and times are absolute, that is, different inertial observers agree on the lengths of objects and the time intervals that have passed. In special relativity, we have seen that these things are relative or observer dependent. However, now that we have a mixing of space and time, we will see that two different space-time points are connected by a measure which is called the space-time interval, and this measure of distance between two space-time points, it turns out to be exactly the same for all inertial observers. Then we will talk about the concept of space-time diagrams. How can we graphically represent events that are occurring in space and time? We will find this very useful when we try to understand various paradoxes that arise in the considerations of special relativity. Now, we've seen that in Galilean relativity, we have certain quantities that are absolute. That is, all observers, all inertial observers, agree on the values of these quantities regardless of the coordinates that they're using to describe phenomena. So, for example, lengths in Galilean relativity are absolute. The length of a rod as measured by one inertial observer is exactly the same as the length of the rod as measured by another inertial observer. Time intervals are absolute. A time interval that is elapsed for one inertial observer is exactly the same as what has elapsed for another inertial observer. In special relativity, however, we have seen that lengths are relative. Moving rods appear to be shorter. Time intervals are relative. Moving clocks appear to run slower. So, though we have absolutes in Galilean relativity, we haven't yet talked about what quantities could or would be absolute in special relativity. That is, are there any quantities that are exactly the same for all inertial observers in special relativity? Okay, so things which are absolute, which all inertial observers agree on, these things are called invariants. Okay, so in particular, lengths and time intervals are called Galilean invariants because they do not change, or they're invariant, they do not change under a Galilean transformation. So what we want in more formal language is to find special relativity invariants, things that do not change when we switch from one inertial observer's description to another inertial observer's description. In other words, if we are looking at our dictionary of special relativity, and we talk about several observers, S prime, S double prime, so on, what we're asking is there a word in the dictionary which for observer S is exactly the same as the word observer S prime uses, which is also exactly the same as the word S double prime uses, and so on. So in the other way of describing this is we are looking for universal words for our dictionary. A word that is the same in all languages of all these observers. We know one example of such a word. The speed of light c, as described by observer S, is exactly the same as the speed of light S prime, seen by S prime, and is exactly the same as the speed of light seen by S double prime. So we already know an example of one such word, which is the speed of light. So now the question is, are there other invariants or other universal words in the dictionary of special relativity?